Today we're going to learn how to graph tangent and cotangent. So what you want to remember first is tangent is sine over cosine, and then cotangent is cosine over sine. So what we're doing is kind of remembering how we were graphing uh, cotangent and cosecant and secant, where we're looking at the denominator function because we're saying this function, because it's in the denominator, when it's equal to 0, it's going to create a vertical asymptote, which is not okay. So then we want to focus on that function first. Okay, so let's go ahead and graph this. So for example, let's go ahead and just do a general one. So we're going to do a general tangent graph. Tangent, again, is sine over cosine. So then you ask yourself, which function is going to matter as in creating the asymptotes? Well, that's going to be cosine because it's in the denominator. So what we want to do is first graph cosine. So we've, graphed cosine for a long time now, so we should be pretty good at this. So we can see that this cosine graph has an amplitude of 1. B is equal to 1, therefore period is 2 pi over 1 or 2 pi. So we're going to just graph that tangent. Graph the cosine. So 2 pi, break into half, break into half again, and we're going to draw a cosine. So we're going to start on the top, goes down, down, up, up. Connect the dots. We do it on the left, 1 period, half period, quarter. So down, down, up, up, connect the dots. All right, so that's the cosine graph. Now from here, we're going to draw a tangent. So the first thing is we need to figure out when cosine is hitting the x-axis because that's where it's 0, and then that's going to be the vertical asymptote. So we can see that's here and here. All right, that's pretty good. Next, what we're going to do is we're going to look at two asymptotes, any two asymptotes, um, and then the tangent graph is going to be right in the middle. So right in the middle between the two asymptotes is the 0 mark. Next, we're going to mark halfway between the where I marked this and then the asymptote. So halfway between that, which is right here, and then same thing here on the left, halfway in between. I'm going to make 2 more marks like that. And this time, what we're going to do is we're going to go up to the amplitude. So the amplitude in this case was 1. So on the right-hand side, this mark goes up to the highest amplitude, and then here goes down to the lowest amplitude. So we're going to make 2 marks there. And then we're going to connect the dots. Now, tangent is not like this. It's actually a very smooth curve, but what we're saying is it has to go through those 3 points. And then because there are vertical asymptotes, the graphs are going to go towards the vertical asymptote like so. So it's getting closer and closer to the vertical asymptote. All right, let's pick another 2. So again, in the middle is the zeros. Make 2 more marks in between the starting point and the asymptotes. On the right-hand side goes up to the highest point. On the left-hand side, it goes to the lowest amplitude, and then we connect the graph like so. All right, let's draw one more. So middle, half, half. On the right-hand side goes up, on the left-hand side goes down. Connect the dots. All right, that is the tangent graph. All right, let's go ahead and have you practice this. 2 tangent 2x. 2 tangent 2x. So remember this, we're going to change it to sine over cosine. So what we care about is this function down here. So go ahead and pause the video and then graph the entire tangent. All right, go ahead and check your answer. So you can see that this graph is much skinnier than before because it had a horizontal compress of 1/2 and then also a vertical stretch of 2. All right, let's go ahead and look at our cotangent graph. So cotangent graph is going to follow the same idea. Cotangent is cosine over sine. So we're going to start with sine, and this is the same as before, 2 pi, period, have a period, have a period again. Goes up to to 1, lowest to -1, and we're going to start at 0 because that's how the sine graph goes, like so. All right, and then on the left-hand side, it's the same. So 1 period, half period, quarter period. This one goes down like that. Next, let's go ahead and draw the asymptotes. Wherever the graph hits 0, we have asymptotes. All right, same thing as before. We're going to pick 2 vertical asymptotes, and then right in the center, we're going to put the starting point, and then starting point and the asymptote, we put a mark to tell us that this is going to go up to the amplitude. Now, this is a cotangent graph, so cotangent graph is different from tangent in many ways, but one of the significant ways is tangent goes increasing like so, but cotangent goes decreasing like so. So what we want to do is when we are looking at this point and this point, what you used to do was make this go up and sorry, right hand side go up, left hand side go down. This time, right hand side is going to go down, left hand side is going to go up. So it's kind of the reverse from before. Okay, pick another 2 vertical asymptotes and do the same. Okay, and then my last set of asymptotes. All right. Okay, let's go ahead and again have you pause the video and try this one. So this is again very similar to the previous one where we did 2 tangent 2x. Now you're going to do 2 cotangent 2x. So we're going to start with cosine over sine. And we care more about sine because it's in the denominator. So go ahead and pause the video, try it, and then come back and check your answer. All right, go ahead and check your answer. All right, so now we're going to again draw the graph and then analyze it. So this one we already drew before, but let's just for practice sake do it again. All right, so this is tangent. So tangent is sine over 2 cosine. So I'm going to start with cosine. This is 1 period is pi, half period, quarter period, and this is cosine 2x. So we're going to start on the top, goes down. Do the same thing on the left. All right, from here, we're getting the vertical asymptotes. All right, halfway in between, starting point, halfway goes up. So this is tangent. So on the right-hand side goes up, and then on the left-hand side goes down. All right. Okay, so let's go ahead and look at our graph and analyze. Domain. Well, we have a lot of vertical asymptotes, so there's going to be a lot of values that it's not equal to. You can see that it's very systematic, it's very periodic. There is a pattern to this. So what we want to do is identify one vertical asymptote and then write as an iteration from there. So one vertical asymptote that's nice to recognize is this one here, pi over 4, because it's half of pi over 2, so pi over 4. And then we kind of ask yourself, how do I get to the next one? Well, to get to the next one, it looks like this length is exactly pi over 2, right? You can see that this is 2 units or 2 squares, and then this is 2 squares, so it must be the same size. That is pi over 2. So that is true. So um, the asymptote is happening at starting with pi over 4, and then every time it goes pi over 2, you have another one. So we put pi over 2n. All right, let's look at range. Range is the y direction. You can see that this graph goes through everything. So this is all real numbers. Increasing. Well, this graph is always increasing, but it's not going to, you cannot put all real numbers because there are vertical asymptotes. So what you want to do is, again, you want to pick two points where you contain this graph. So for example, between the two vertical asymptotes. So what I'm going to do is say, starting from this one to this one, that's one nice tangent graph. I'm going to say this shape keeps repeating. So the left-hand side of this shape is at negative pi over 4. On the right-hand side is pi over 4, but I know this shape is repeating itself every pi over 2. So what I'm going to do is write this. So starting from negative pi over 4, it will repeat itself every pi over 2, and then it will end at pi over 4, and then that shape also repeats itself pi over 2. And then you can see that I'm also writing parentheses because there are asymptotes, there are no actual points, so we don't include them. Decreasing, this graph is not decreasing. Continuity, this is again infinite discontinuity. Symmetry. All right, so symmetry, again, you ask yourself, can I fold it across the y-axis and that it will look the same? No, it will not. Next, you can put your finger around the origin and then turn your graph 180. Does it look the same? Yes, it does. So this is odd. Boundedness, this graph goes up and down forever, so this is not bounded. Local max and min, well, this one does not have any of those. Vertical asymptote. Well, vertical asymptote is exactly the same as the domain, but this time we put equal to, not equal to, because it is asking us, where are they then? So you had to say, well, they are at, so you're using equal to. And behavior, because the graph keeps going up and then restarting and restarting, so this is no end behavior.